So welcome. So it is a problem number 4 from CAD solution book in the isometric projection. You can see here the following figure shows the top view of a cylinder. So here cylinder which is centrally mounted on a frustum of a pentagonal pyramid 60 mm height. Okay. So you can see in this problem, so this is our question. Okay. You can see in this they will be giving this top view of it. You can see that one pentagon of dimension 50, another pentagon of dimension 20, and this is our cylinder which is having a diameter of 40 and length 100. Okay, so they will give this one. So for this one, we know, as we have discussed, so if the polygons given like triangle, pentagon and hexagon, we have to draw the orthographic of it. So herein I have drawn a pentagon of dimension 50, another pentagon of dimension 20. Okay, so in this above it I have placed a cylinder here of diameter 40. You can see it. So first I am constructing this pentagon. Okay, here because it is in frustum, so herein I will take draw an reference line here. Okay, so say this is our reference point. Say here first I will construct this from 1. You can see that from 1 to 2 we have 80. 80 means 8 boxes. 2, 3, 4, 5, 6, 7, 8. Okay, then so this point it is 2. 2 to 3 we have 75. 75 means 7.5 box. 1, 2, 3, 4, 5, 6, 7, 7.5. Then this point is 3. Again from 3 to 4 it is 80. 80 means again 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this point it is 4. So now we are going to join. Okay. After that you can see 1A and 2B. With 2 to B it is 15. That is 1.5 bucks. These two lengths were same. Okay. So first I am marking 1 to A. 1 to A it is 15. 15 means 1.5 bucks. This is A. Then 2 to B. See 2 to B it is also 15. 15 means 1.5 bucks. Okay. Now from 2 to C. Okay. So 2 to C we have. So we have to measure. This 2 to C we have, it is around 48 mm. Okay, so here I am going to mention it. It is 48 mm. Okay, so 2 to C. 2 to C it is 48. So 1, 2, 3, 4, 48 means it is around approximately here. It is C. Now from 3 to D it is 40. 40 means 4 boxes. 1, 2, 3, 4. It is D. Now again from 4 to E, so I can take 1E. 1E it is exactly equal to 2C. That is 48. 1, 2, 3, 4. 48 means it here. That will be E. Now we are going to join these points to construct the pentagon. Okay, so it is done. Now so they have mentioned a height here. Okay, height of 60. So from this corner point we will be moving a height of 60, then we will construct this pentagon of 32. Okay, so from these corner points 1, 2, 3, 4, 5, 6. Okay, this point. Then again from this point 1, 2, 3, 4, 5, 6. Okay. From this point 1, 2, 3, 4, 5, 6. And this 1, 2, 3, 4, 5, 6. Okay. So here we get another box. So we will construct. So remember, you should consider this only height, not the, don't draw vertical line. If you draw a vertical line, it will become prism. Okay, so remember it. So after getting the box here, so you can see this is our box of 32 by 19. So we have to subtract. So either here we have to get inside box of 32 by this 32, and we have this one we have to measure, and this is 32 by 30 box you have to get. Okay, by 30. So how to do it? We will subtract with the, say, this 80 mm with the 32, this 75 with the 30. So that's how we do it. Subtract 80 minus 32 means it is how much? It is 48. Okay, so 48 divided by 2 means it is 24. So on the 80 mm side, so on the 1, 2 and 3, 4 we have to subtract by 24. Say here in this 24 means 20, 24 here 1 point, and from this end also 20, 24 here also 20, 24, 20, 24. Okay, now again this end 75, this is 75, this is 30. 75 minus 30 means it is 45. So 45 divided by 2 means it is 22.5 on the 60 mm side. Okay, this is 60 mm, this is 75 mm, so in this 22.5. So 22.5 means here in here 15, 25, 22.5 means here, and the same thing here also. So 22.5, so you have to mark, right? This 15, this is 20, 22.5, and here also it is 22.5, and here also it is 15, 20, 22.5. Now we are going to draw the lines. Okay, so now we are getting a box of here 32 and 30. Okay, so this is our box of 32. So I'm going to mark this is 1, 2, 32, 3 and 4. So this is our box. Okay, getting a box. Now 1 to A. So 1 to we have A, it is 6. Okay, 6 means here I will mark this is A. Again from 2 to B it is also 6, this point. Then from 2 to C it is 19. So 19 means 19, 6. Again 3 to 4, 3 to D it is 16. So 16 means exactly here at the point, this is D. Again from 1 to E, you can see that 1 to E and 2 to C it is same, 19. So 1 to A it is 19, and that means it is E. So now we are going to join. So approximately we have to mark it. Okay, so here also we get the pentagons. Now we have to draw the slant edges. So we have to connect A with the A, B with the B, and C with the C. Okay, slant edges. Okay. So it is frustum of pentagonal pyramid, it is done. Now we see in this diagram from the center point, so it is at a distance of 20 because it is 40, right? So what we do, so this is our box. We will draw a perpendicular bisector. Okay, so this is our center point. This is from this center point. From this center point, we have to consider a box of 2. Okay, so from here, this point, box of 2, 1, 2. Okay, here also 1, 2. We have to consider, and here at the distance of 20 and 20, we have to draw. Consider a from this end to from this end 5 boxes. Okay, because total length is 100. You can see that the total length we have here, it is 100. So from these marked points, we have to consider 5 boxes. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. This end also 1, 2, 3, 4, 5. Okay, from this end 1, 2, 3, 4, 5. Okay, so we're getting here the 100 mm. Now from here we have to construct a box of 40. You can see that it is of diameter 40. So from this end 1, 2, 3, 4. In this end also 1, 2, 3, 4. So what we do, so we have to draw a cone here. So this is 40. From here we will be moving vertically 1, 2, 3 and 4. In this end also 1, 2, 3, 4. Okay, so we have to join it. Okay. So after this, so from these corner points we'll be marking middle points. Okay, exactly the middle points. It is to draw ellipse, we are going for 4 arc by center method. So ellipse is done. So here in this point also, these two are the end points. Again here 4 boxes we have to consider. 1, 2, 3 and 4. In this point also it is 1, 2, 3, 4. Again marking the middle points. New drawing in 4 arc by center method. again we have to construct the cone here. Ellipse is constructed. Now we have to join these two ellipses to draw the cylinder. Okay. So we'll be joining these corner points. Okay, remember these corner points will be joined. So this completes the problem. Okay. Problem number 23 from isometric projection from CAD solution book. So in this problem they have given frustum of cone base diameter 50 and top diameter 25 and height 50. So frustum means it is a cutted portion of the cone. Okay. So frustum means it is a cutted portion of the cone. So base diameter 50, top diameter 25 and height 50 is placed centrally on a square slab of side 100 and thickness 30. So first we have to construct a square slab. Above it we have to place the frustum of cone. Okay. Square slab of side 80. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. So thickness 30. 30 means 3 blocks. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So square slab is constructed. Now frustum of cone diameter 50. So this is 80. So base diameter 50. So 80 minus 50. So it is 30. Divided by 2 means it is 15. So 15, 1, 5, 15, 15, 15, 15, 15, 15, 15. Okay, so this is our square of 50. So here we have to construct a ellipse here. So marking the middle point. So on top diameter 25, so we should consider a height of 50 from this 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. So we have to subtract in this, but you can see that top face diameter 25. So we have, this is 50, again we have to subtract 50 minus 25 divided by 2, it is 12.5. So 12.5, this is 5, this is 10, 12.5, 10, 12.5, 10, 12.5, 12.5, 12.5, 12.5, 12.5, sorry, 12.5, 12.5. So here now this is our square. So midpoint we have to mark. So now so two ellipses are constructed. Now we have to join tangentially. Okay. So this completes the problem. Okay. Welcome to Engineering Visualization channel. Problem number 23 from CAD solution book. A frustum of cone diameter 50, top diameter 25 and height 50 mm is placed centrally on a square slab. So first we are going to know what do you mean by frustum. Frustum means it is nothing but cut portion of the solid. Okay, cut portion of the solid to a particular height. So here you can see, here it is a frustum of cone. I am going to write that how it is look in front view. So here in the frustum, it consists of frustum of cone. It consists of two circle here. One is 25 mm top circle, and the base circle here it is 50 mm diameter. Okay, so and it is having a there are two circles which are at a height of 50 mm given in the question. That means both the top and the bottom part will be the circles which is of diameter given in the question. Place centrally on a square slab of 80 mm side and thickness 30. So first diagram we have to construct, that is a square slab. Square slab dimension given, side of 80 mm, and height, that is thickness given, that is 30 mm. Okay. So above it we have to construct the second diagram, that is our frustum of cone. Okay, in order to construct the frustum of cone, they have given the dimensions here. So base diameter given, it is 50 mm. Okay, base diameter 50 and top diameter 25 mm. Okay, and height also given, height it is 50 mm. Okay, so first we need to construct in isometric, that is our square slab. Okay, square slab. First I will be drawing one horizontal reference line. Okay. Okay, to construct the square slab, they have given the dimension 80 mm side, that is 80 mm box we have to construct. So here square slab will be constructed using box method. Okay, first I will be drawing one horizontal line. Okay. Horizontal line. Okay, mark one reference point here. So here 80 mm means 8 boxes we have to count. So 8 boxes. Okay, so join all these points to get a box here. Okay, try to join a straight line. Okay, so again count 8 boxes and mark a point and then connect now. Okay, now we have to give the thickness here for this box. Okay, and it is, you can see all these lines were at an angle of 30 degree. We can show this 30 degree angle. Okay, and here given it is thickness 30, 30 means 3 boxes. Vertical height we have to consider. Thickness means it is nothing but height. Okay, 3 boxes you can mark here. 1, 2, 3, 1, 2, 3. Here also 1, 2, 3. Okay, draw the vertical lines here. Now connect these top end points with the box here. Okay, so here square block it is completed. Okay, now we have to complete this frustum of cone. For this they have given base diameter, top diameter and height. Okay, on the top of this square slab we have to place the base of 50 mm. For this we will be using subtraction method. Okay, subtraction of box method, we can say that. Say subtracting the boxes. Here we have top box of 80. So we need to subtract with the 50. 80 minus 50 means it is 30 mm. So it is on either side means 15 mm. So we need to subtract the 80 mm box. Okay, so at a distance of 15 mm. Okay, we can write 15 mm easily on the top box of 80. 15 here, 15 here. Okay, again 15 here, 15 here, 15, 15. You can mark easily. Okay, now we need to draw the where we have marked these points, right? We will be drawing with the thin lines here. Okay, now we'll get another box here, another box inside. What we get, that is of dimension 50 mm. Okay, 50 mm. Now here we have to construct a circle. When it is constructed in the isometric, Okay, it will be constructed as a ellipse here. Okay, ellipse. So we will be using 4 arc by center method. So draw the ellipse. So here, as we know, the circle will be converted as an ellipse here. So ellipse will be constructed using 4 arc by center method. 4 arc by center method, you can say that. Okay. First I will be marking the midpoint of this 50 mm. Okay. So mark the midpoint here of the inside box, exactly midpoint at 2.5 you can mark. Now draw the lines here, 4 lines you need to draw. Okay. Okay, so we have drawn the 4 lines here. Now measure this line and draw an arc here. We have to draw an arc. Okay, now taking that as a reference point. Okay, you can subscribe to the channel and hit on the like button and share to maximum students so that they can be benefited. Okay, these are all the problems in the CAD solution book. It is very helpful for the first year engineering students. So they are studying this engineering graphics or computer aided engineering drawing subject. Now we have completed the base diameter 50, that is we have drawn an ellipse here. Now by taking 50 mm the inside box, so we have to consider the height here now. The height of 50, so count the boxes. So here the box count, it is coming from exactly the center of it. So count 5 boxes, and again here we need to construct another box of 50. Okay, from there we'll again subtract, so that we'll get another box of 25. Okay, now I'll be drawing another box here, box of 50 by 50 at a height of 50 mm. Okay, just we need to count here, don't draw vertical lines. If you draw the vertical line, it will become prism. Okay, so it will become prism. So connect it with the thin lines here. So box of 50 by 50, you got it. Now here the top diameter, it is 25. So but we have drawn a 50. Again now subtraction of box method. 50 minus 25 means it is 25. So you have to subtract on either side, means it is 12.5. 12.5 mm we have to mark. You can see on this the top box. So this is 10 here. So 10 means it is 12.5 here we have to mark. In the same way here also 12.5 we have to mark. Okay, on this side also we have to mark 12.5. Okay, here also on the top box we have to mark 12.5. Here also 12.5. Okay, 12.5 we have to mark. Now draw the lines where we have cut it exactly at 12.5. Try to connect with these lines so that we get another box of 25 mm. Now you can see the inside we getting a box of 25 mm. Okay, the inside box, we'll consider that as a reference. Yeah, those are the corner points of that particular box. So mark the midpoints now. Again we use the 4 arc by circle method, 4 arc by center method to construct the another ellipse, because that is a frustum of the cone. Okay, in a frustum of cone we have both top and bottom will be the circle. So when it is constructed in the isometric, it is becoming as a ellipse. Okay, So subscribe to my channel and hit on the like button and share it to maximum students so that they can be benefited. Okay, draw an arc here to construct the same way how we have constructed the bottom ellipse, right? Same method we have to do it. Now draw horizontal lines connecting the corner points here. So now join here. Tangentially you can draw here. Okay, so that completes the problem. So here you can see we have completed both. This is nothing but your square slab and this is your frustum of cone. Thank you all. Thank you for watching the video. Subscribe to my channel and share it to maximum students so that they can be benefited. Thank you guys. Problem number 25 from CAT solution book. So it is a problem from isometric projection. A hemisphere of diameter 50 mm resting on its curved surface centrally on the top face of a frustum of a rectangular pyramid of base side 80 into 60 and top of 60 into 40. So with the height given 55. So first we have to construct a frustum of a rectangular pyramid. Okay. So first we construct this 80 into 60. Now, so we need to consider a height of 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. 1, 2, 3, 4, 5, 55. So we need to get a top of 60 into 40. So that is 80 minus 60. 20 by 2 is 10. 60 minus 40, 20 divided by 2, 10. So on the either side we have to subtract by 10 here. So now we are getting so first term of a rectangular pyramid, it is done. Now you have to keep the hemisphere of diameter 55. So for that you need to consider a height of 25. So 1, 2, 2.5, 1, 2, 2.5, 1, 2, 2.5, 1, 2, 2.5. Here another box. But here we need a box of 50. So here we have 1, 2, 3, 4, 5. So this is 50. But this one is it. 1, 2, 3, 4. Here. So this will become 50. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 50. Okay. This is 58. But here we get 1, 2, 1, 2, 3, 4. Now we see it, and this is our box of 50. So marking the entry points. So from this point, measure on this length. Okay. Okay, so this completes the problem. A regular pentagonal prism of base side 30 mm and axis 60 mm is mounting centrally over a cylindrical block of 80 mm diameter and 25 mm thick. So draw the isometric projection of the combination of solids. So here I will be drawing a top view, orthographic view of this pentagon and then a circle. First I will be constructing a pentagon of dimension 30 mm. So draw a vertical line of 30 mm. So take protractor and mark for 72 degree. You all know how to construct the pentagon with the angle of 72 degree. Okay, draw a line of length 30 mm passing through that angle point. Okay, so here also you need to mark for 72 degree and draw a line of length passing through that angle point, a length of 30 mm. Okay, so now you take compass, measure 30 mm and cut the arc. Okay, so now you join with the help of a scale, straight line you draw connecting it. So this completes the pentagon dimension 30. Okay, so now to find out the center of this, I'll be drawing first I'll be drawing middle points to draw the perpendicular bisectors. Okay, at least I will draw 3 perpendicular bisectors marking the middle points. Okay, so this is how you have to draw the perpendicular bisector to find out the center of the pentagon. So here I have drawn 2, so I need one more. Okay, one more. So mark the middle point. Okay, so 30 means exactly you need to mark for 15 mm here. Okay, so okay, after constructing it, so show the dimensions. So it is having a dimension of 30 mm. Okay, okay, now we should construct a box for this, because we will be constructing using box method in the isometric. Okay, that's why we need to construct the boxes here, or the extremities of this pentagon we will be drawing horizontal and vertical lines. Okay, so that we can able to construct a box for the extremities of this pentagon, so that within this we will get a rectangular box here for this pentagon. Okay, we should construct it. Okay, I can measure the dimension and show it. Okay, it is around 49 mm we get here. Okay, the middle point of that will be 24.5, and this is we getting around 45 mm. Okay, and this one also we should measure. This is we are getting around 28 mm we get here. Okay, the total length we get, it is 45. We should measure these lengths because so it will be helpful when we construct this pentagon. So because it is in polygon, so that's why we should have all these lengths. If we measured these lengths, okay, box dimensions and this end points length, so it will be easy for us to construct it. Okay, so it is having a length of 45 mm. We will show it. Okay, now from the center of that we will be constructing a, here it is a cylinder block, means it will be a circle. So the diameter given 80 mm, so we will be considering a radius of 40 mm here. Okay, then we construct a circle here. So that means it is having a box dimension of 80. We no need to see, but we can show only the dimension. So we will show the dimension on one side. So the box dimension of this cylindrical block, it will be 80 mm. Okay, now we need to construct the isometric of it. So you can see we have the first we need to construct a box of 80 by 80, that is 8 by 8 box. First I will draw a reference line. Okay, then we'll take a reference point. From that reference point, okay, I'll be counting 8 boxes. Okay, 2 3 4 5 6 7 8. This side also I will construct the same thing, 4 5 7 8. Okay, so construct the box first. So here it is a cylinder, means we should construct the ellipse here. We should construct the ellipse here, 2 ellipse at a height of 25 mm, because it is having a thickness of 25. So the height we should consider, that is 2.5 box. 1 2 2.5. Okay, again same thing we should do it for all these extremities, 2.5. Again 1 2 2.5. 1 2 2.5. Okay, so here also we should construct another box of 80, that is 8 by 8 box, 80 mm, 80 by 80 mm. So we should join these points which we have taken. Okay, so now we got the box again here. So now we should mark the middle point of this box. So it is 80, means exactly at 4 boxes. Count it perfectly, 1 2 3 4. Then 1 2 3 and 4. 1 2 3 4. Same thing here also, 1 2 3 4. Okay, count again, 1 2 3 4. So mark it properly. Now you draw the lines from the corner of the point to the opposite middle point. Here we are following 4 arc by center method to construct the ellipse. You all know how to construct it. Okay, 4 arc by center method. Okay, then in the top box also we should do the same thing. Okay, now use compass to measure these lengths and cut the arc. Okay, measure the length, any one length. You can construct these arcs same way from the other end. Okay, join it properly. And then from that reference point we construct part of the ellipse. Okay, the same way we should do it for the top box also. Okay, from that reference point. Okay, measure the length and cut the arcs to construct the ellipse here. Okay, now you draw the diagonals for the bottom box and the top box. The straight line you can join, connect. Okay, for this point also you can do it. Okay, now we can join these extremities with the vertical line here and here also. Okay, so now we have to use the subtraction of box method. Okay, so one side we have 80, one side we have 45. 80 minus 45, it is 35. 35 divided by 2 means 17.5. And the other side we have 80 minus 49. 80 minus 49 means 31. 31 divided by 2, we have 15.5. So that means on the one side we should mark 17.5 on the other side of the line, and the other box side we should mark 15.5. It is almost around 15 only. So that's what the thing I'm going to do it on the top box. So on the top box I should mention, okay, you can see here the top box we should mention one is 15, one is 17.5. You can mention it. So first I'll be mentioning 17.5. From this side also 17.5. There also I should mention 17.5, and here also 17.5. Now on the other side we should mention 15. 1.5 we should mention 1.5, 1.5, 1.5 and 1.5. Okay, so now we'll draw the lines connecting these points. Okay, and join these reference points also with the straight thin lines, because we will get a box here for, we'll get a rectangular box for this pentagonal prism. Okay, now we need to find out that, and we should dark it so that it will be easy for us to construct the pentagon within that rectangular box. Okay, box of 45 by 49 we get it here. Okay, now you can see we should we have already measured the box in the pentagon. We should use those point lengths such as 9, 28 and all. I'll be marking 9 here, you can see on the either side, and then I'll be marking the middle point, that is 24.5. okay, and then I'll try to join. Still I need to mark 28 here, so 28 I'll be marking. So this is where I'll get 20, 28 here. Okay, here and here. Okay, and then I'll join these points to get the pentagon here. Okay, so by joining all these points we get a pentagon here. Okay, so from these pentagon extremities exactly vertically upward we should move at a height of 60 mm, that is 6 boxes. Therein also we need to construct another pentagon. Okay, another pentagon. So from this extremities point So using scale, we can count the boxes here. Okay, I can count it. You just I'll be using the help of the scale here. That's it. But I'll be counting the boxes only here. Okay, 1, 2, 3, 4, 5, 6. Okay, that is your reference point. Okay, draw vertical line because it is a prism. Same way for this 1, 2, 3, 4, 5, 6. Draw a line. Okay, same way here also. Why I'm using scale means it will be helping to draw a straight line. 1, 2, 3, 4, 5, 6. Can join. Okay, the same way here also can do it. Can count 1, 2, 3, 4, 5, 6. Can join here. Okay, and then here also we can do it. 1, 2, 3, 4, 5, 6. Can join. Okay, now we get a pentagon above it, so you can see that at a height of 60. So we should connect it. Okay, we should connect it. To get the pentagon here. So you can see, so that completes the problem. You can see that the subtraction of the things we have done here. Problem number 39 from CAD solution book. It is a frustum of square pyramid, base side 40 mm, top face height 20 mm and height 40 mm is placed centrally on a frustum of a cone base diameter 80 mm, top diameter 60 mm and height 20 mm. Draw the isometric projection. So in this, first we have to construct the frustum of cone. Okay, for that they have given base diameter 80. So for that we have to construct the box for it. First I am taking a reference line here. So count 8 boxes. So it is a cone means it is a circle. Circle means we have to construct the ellipse here. Okay, we have to construct the ellipse here. Using 4 arc by center method. So taking the compass, we can construct the ellipse here. Taking the lens, measuring the lens. Now on the top circle, it is at a height of 20 mm. So we consider a height here of 2 boxes. Don't draw vertical line here. You have to just count the 2 boxes and draw again a box of 80. So here we need to get a box of 60. So we are subtracting 80 minus 60 means it is 20. So neither side means divide by 2. So 10 we get. So we have to subtract by 1 box here on either side. Now we are getting a box of 60. Just I am marking the corner points of the box. Again 4 arc by center method. Mark the middle point of the box. So it is 60 means mark exactly the 3 box. So again for arc by center method to construct the ellipse here. Here we have to draw a tangential line for the two ellipses with the curved surfaces. Okay, so like this you have to draw in this. So here also same thing. So above it we have to construct the frustum of a square pyramid. So it is having a base of 40. So but we have a top face of 60. So we are subtracting 60 minus 40. It is 20. Either side means it is 10. So height they have given it is 44 boxes. We have to count. Again we have to subtract because top face it is 20. 40 minus 20 it is 20 divided by 2 means 10. So on other side you have to subtract by 10 means one box. Now on the top face we get a box of 20 by 20. We see problem number 50 from CAD solution book in isometric. You see in this problem they have given rectangular slab of side 100 into 80 and height 30 as a full depth coaxial squares all of side 40. So first we are going to construct rectangular slab here. From this end 100, 1, 2, 3, 4, 5, 6, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 100 by 80. That means 10 into 8. And height we have to give 30. 30 means 3 box. Now we have to have a square rule of side 40. So we have 100 into, so 100 minus 40 it is 60 divided by 2 means 30. Then 80 minus 40 means it is 40. 40 divided by 2 means 20. So on the 100 mm side, so we have to mark up 30. So on the 80 mm side we have to mark up 20. So now we got the square of 40 here. I am going to mark it. So this is 40. So we have to give a height of 30. This is thickness having 30. That means you have to give a depth of 30 here. So thickness 30. So vertically so 33 box. Then we have to so 30. So you can see that so this completes the problem. Square prism of base side 40 mm and height 50 mm is placed centrally on a cylindrical slab of diameter 100 mm and thickness 30 mm. So here first we should construct a cylindrical slab. That's why I given number 1 cylindrical slab. First we have to construct. Okay. Second thing we should construct above of it, that is a square prism. So the dimensions we can write down. So 100 into 30. This is 40 into 50. Okay. Okay, in the isometric sheet, you take the reference line. Okay. Okay, from this reference we should mark 110 boxes, that is 100 mm, right? We should mark 10 boxes on either side. Okay, so construct the square box here. Square box for 10 by 10. So we should draw here thin line for the square box because it is a cylinder. Okay, Okay, that's why we should construct this 110 by 10 box, that is 100 mm, with a thin line. Okay. Okay, now we should consider a height of 30 mm. Okay, thickness given 30 means 3 boxes we should consider, and we mark a reference point 1 2 3 1 2 3 1 2 3. Now here we should construct another box of 100 by 100, that is 10 by 10 box. Okay, 100 mm box you have to construct. Okay. Okay, after constructing this box of 10 by 10, we should construct the ellipse here. Okay, 2 ellipses you have to construct, and then we have to join to construct the cylinder here, cylindrical slab. Okay, so use the compass. So first we should mark the middle point of all these boxes. So mark the middle points for the both the top box and the you should mark exactly at the 5. Okay, midpoint we should mark. Okay, so after that we should draw a lines here from the corner point. Okay, either you can draw first, you can draw for the bottom face. See, from the corner point, so to the middle point what we have marked, we draw a line here. We know how to construct the ellipse, so we are following the same concept. From that middle point we are joining with the corner point here with the line. The same thing we do it for all the middle points. With the corner points we are trying to join here. Okay, and the same thing we will be doing on the top box also. So here I can use this length to construct the ellipse here. Okay, okay, then take this as the reference point. So measure this length carefully, you can cut the arc. Okay, so that is also having the same length, so you can cut here also by considering that as the reference point. Okay, now the same way we do it for the top box also. So we try to connect with this corner point with the middle point of the box with a straight line. Okay, okay, now we construct the ellipse here by measuring the lengths here. So measuring these lengths, you can construct the arc here. So measure it properly and construct it. Same way we should do it for the other side also. Measuring this straight lines length using compass, and we construct the arcs here. Okay, the same way do it here also. Okay, so now we got 2 ellipses here using these 2 boxes. Now I'll be drawing a straight line connecting these opposite corners. Okay, now we are going to join these points, okay, vertically with the straight line. Okay, that completes the cylindrical slab. Now above it we have to place the square prism, which is having dimension of base side 40 and axis length 50. So we have to go for the subtraction of box method here. So we have the box of 100. 100 minus 40 means it is 60. So we have to divide on two side means it is 30. That is 3 box dimension we should mark on the top box here. On the top box we should consider 3 box. On all either sides we should mark 3 box here to go for the subtraction of box method. It's because we should get a box of 40, right? Because square prism having a dimension of 40. So we can subtract by 30 mm on all the either sides. We can subtract it easily. Okay, now we get a square here of dimension 40. Okay, so for the square we should consider a height of 5 boxes, so that is 50 mm from all these corner points. Consider a 5 box height from all those corner points. Okay, now draw the top face dimension 40 by considering a height of 5 boxes here. Okay, just draw connecting these two square faces by the vertical edges. Connect these corners with the vertical line here. Okay, so I can mention the angle 30 degree for the base where we have taken a reference. Okay, you can see this is our second right cylindrical slab, dimension 100 into 100 and height 30. This is a square prism, dimension base side 40, height 50 mm. So that completes the problem. Problem number 49 from CAD solution book in the isometric. You see in this problem, a square prism side 40 mm and height 50 has a full depth coaxial square hole. Okay, full depth coaxial square hole, side 20. So it is one of the type of problem. Okay, it is a different type. So just see it how to do it. Just taking the reference line from here. So it is of side 40 and height 70. 40 square, that is 4. 1, 2, 3, 4. 1, 2, 3, 4. And height 70. So height 70 means 7 boxes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it is a square prism, then we have to draw these vertical edges. Now it is having a square hole size 20. So this is having 40. So we are going to subtract 40 minus 20 is 20. Either side means divided by 2. It is 10. So subtracting by 10 either side. So here we have the square hole. So this is our square. So I'm going to draw it onward. So this completes the problem. Draw the isometric projection of a rectangular prism, dimension 60, 80 into 20 mm thick, surmounting a tetrahedron of sides 45 mm, such that axes of the solids are collinear and at least one of the edges of both the sides are parallel to VP. So you can see here in this I have drawn the orthographic of the tetrahedron, both the top and front view of it I have drawn. You see that, that's what I am writing. Orthographic view of tetrahedron we required to construct here. Okay, you can see initially I have constructed a 45 mm triangle. Okay, then after that I have taken a mark the points, and then I have marked the middle point of all the edges to draw the medians here, and then you get the exact point. You need to draw the medians here, remember. And then I have projected the lines, and we don't know the axis length here, just projecting the line, and you can see the edge OBT is parallel, so we should measure 45 mm and cut the axis. So we should cut with respect to the 45 mm. We need to find out the axis. Here the axis length what we get, that is 36 mm. Okay, now after that we have to construct the box for it. Okay, we need a box. One side we have 45, another 40, and the exactly half of that, that is 22.5. okay, now we need to construct the isometric of this. Okay, first we will be constructing a rectangular prism, then above that we will be constructing this tetrahedron. Okay, I'll be using the isometric sheet because it is an isometric problem. So first take a reference line. You can see that. So first we have to construct a rectangular prism, so which is having a dimension of 60, 80 into 20 mm thickness. Okay, I'll be constructing a first I will take a reference line, then I'll be constructing a rectangular box which is of dimension 60 into 80. Okay, then after that I'll give the height of 20. So first you draw an reference line. Okay, you take one reference point. So from this reference point you consider the boxes here. Okay, 60 means 6 boxes. Okay, and 80 means 8 boxes. 1 2 3 4 5 6 7 8. Okay, now we can construct it. Okay, 1 2 3 4, can again recheck. So now we have to construct the box here, rectangular box, rectangle. Then after that we will be giving a height of 20. Okay, here exactly at all these points we need to give a height of 20 mm. Okay, you can see in the problem. So the thickness we should give, that is 20. Okay, that is 2 boxes height we have to consider vertically. Okay, thickness we consider in vertical height. And then rejoin to construct a rectangular prism. Okay, So join all these extremities to construct the rectangular prism here. Okay, you can mention the angle 30 degree on either sides. Okay, so now we can see we have this rectangle of dimension 60 into 18, but we need to place this tetrahedron, which is I need to place this 45 on this 80 and this 40 on the 60. So we will be going to the subtraction of box method here. 80 minus 45, so that will be 35. So 35 divided by 2, because we should consider on both the sides, that is 17.5. In same way, the another side we have 60 minus 40, so it will be 20 by 2 means 10 mm. So we need to mark on the longer side, that is 80 mm, that is 17.5. okay, 17.5, that is more than 15. okay, in between 15 and 20 we should mark, okay, approximately, and then 10, so we can count exactly one box here. Okay, you can construct the thin line here. Okay, okay, so now we get the internal box dimension 45 and 40. okay, that's what it is, the box dimension of the tetrahedron, right? So you can mark the middle point and you join to construct the base of the tetrahedron. So base of the tetrahedron, it is a triangle. Okay, now we can find out the center of the box here. Okay, center of the box we find out. So for that we will drawing to take middle points here, and then we draw middle point of the box we consider, and we have to take the center point here. Okay, so we can consider the middle point of this by drawing median also we can do, that is also we can do it, or either we can consider the middle point of the box. So both the things are we can able to do it. Okay, whichever you find feasible you can follow that. So I will be considering here middle point of the box. Okay, from that center point we will be considering a height of 36. So that's what we have been find out from the orthographic height. We have been find out that is 36 mm. Okay, that's what we have been find out. So we'll be considering a height of 36 means 3.5 box, more than a half box, a little more than the 35. Okay, so you'll be drawing an axis line here. Okay, and then joining with the base of the triangle. So we should connect it. Okay, okay, so that completes the problem.